So what we're looking at now is that we're going to be looking at descriptive statistics, which basically is taking what we learned in the previous section, which was sample gathering and data gathering, going through clinical studies or capture recapture, quota sampling, convenience sampling, all those different things. And now we're going to be able to look at that data and put it in a way so that anybody, you can pick somebody off the street and you can show them something and go, hey, look, this is better than this, and here's why. And you'll be able to show it based on an image, which everybody likes looking at image instead of numbers, because for some reason people are scared of numbers. I don't know why, but they are. So let's say I have this. So in the last 25 games, I kept track of how much a team has, how many earned runs a team has given up in the last 25 games. And so here's the numbers. Now, if you gave somebody this and said, hey, look at this, you know what I found out was that you know, they've been giving up like an average of this many runs per game. And the person's going to look at you and go, really? You can tell that just by looking at all those numbers? And you'll go, yes. But they're not going to like it because it's not an easy way to read it. I mean, looking at these numbers, I couldn't tell you what the average is just staring at these numbers. And I'm sure the average person probably can't either. I mean, there's certain things you can probably point out, like there's a couple zeros there and ones. I mean, it looks like there's a lot of ones in there, but there's no way of being, oh, you know, this is what I think it's close to. I think it's close to 3. No, not by looking at that. So what we want to do here is that we want to be able to put it into a way so that it's easier to read. And the way of doing this is something called a frequency table. And a frequency table basically is that you create a table. One column is going to be the list of whatever it is you're breaking it up into. So in this case, I've got runs. I've got 0 to 8 runs. And then the next column is how often each one occurs, which is the frequency. The frequency is how often something occurs in a given set. And so from here, 0 runs 3, 1 run 5, 2 runs 2, 3 runs 2, etc., etc., etc. Okay? So from here, we're able to look and go, oh, hey, look at that. The one that was most common was actually 1. You know, there wasn't a lot of 7s. And now if you add up the frequency, you should get 25. If you had 3, 5, 2, 2, 4, 2, 3, 1, 3, you're going to get 25. Now from this frequency table, what we can do is that we can put this into a graph, or a table, a histogram, a bar graph. We can put it into a bar graph. And basically what this bar graph is this is the easiest way of reading this. So you show somebody this histogram or this bar graph and you go, hey, look at this. Look at the stuff I found. Look at, and they're going to be like, yeah, this is exciting too. And then you can both celebrate and go like give high fives to each other. Yeah, because you guys just did stuff with the frequency table histograms. But see, a histogram is an easy way of showing it, and we'll talk about the other ones that we're looking at. So now, let's say you have this case. So I've taken some lengths of movies. So we've got movies like Ferris Bueller and Major Leagues and Groundhog Day and Napoleon. And so right here I've got the lengths of movies. So I took 25 random movies, and these are in minutes. Okay, so each of these are in minutes. And as you see here, we don't have a small set like the previous one. We had 0 to 8. Here, our lowest one's 80, and our largest one is actually 189. So we've got this big range of numbers, and if we were to make a histogram here, we're going to have 109 separate numbers to make a histogram for, or a frequency table. And we only have 25, so a lot of those are going to have 0. Well, that's just kind of a waste of space and a waste of time. So is there a way of us shrinking this? And yes, there is. Yes, there is. Yes, there is. And what that's called is that's called a class interval. And basically what the class intervals does is it takes the larger set and breaks it up into smaller chunks so that we can take the frequency of a group of numbers, a range of numbers, instead of the whole thing. And to do this, what you're going to want to do is you're going to take the largest number, subtract it from the smaller. Okay? In this case, we've got 109. And then you're going to divide it by approximately how many intervals you want. Okay? So in this case, if I want to divide it by 10, okay, that gives me 10.9, which I'm going to round up to 11. So now all my intervals are going to be groups of 11. So I'm going to start with my lowest number, 80, and I'm going to go up 11. And going up 11 from 80 gets you to 90. You include 80 in this. And then the next group is going to be from 91 up to 101. And then it's going to be 102 to 112, and et cetera, all the way up until you get to the top. Okay, and so that's what you're going to do, and then you're going to make a frequency table with these ranges of numbers. So everything from 80 to 90 will be thrown into one. Everything from 91 to 101 gets thrown into that one. Okay, and it makes it easier, and that we can group those together. Okay, now there's the three different graphs that we have. The first one is called a histogram, or you might like to call it a bar graph, but to be professional here, we want to call it a histogram. And so basically a histogram, you see how this one's a connected one? We would call this a continuous histogram. It's a continuous graph. So this next one is a pie graph, this one in the middle. You've probably seen this, you've probably dealt with these. So this is a pie graph. Now the one thing that you want to know is that to find this measure right here, this angle, the central angle, what you're going to do is that you're going to take the percentage and you're going to multiply it by 3.6, and that tells you the degree of that angle. So that 10%, the degree of that angle is 36 degrees. Hey, pretty easy. So it's percent times 3.6. Okay. Now the last one is called a pictogram, like a picture and a histogram mixed together. And so what we have here is that each one of these images represents some sort of weight. So a dog could be worth 10 dogs. Okay, so a whole dog's worth 10. And basically what a pictogram is it's kind of like a, hey, look at this, is kind of cool. Look at these cute little turtles and rabbits that I've thrown in here. You know, we don't care about these cats because they're cats, but you kind of put an image in there just to make it connect more with what you're trying to do. Okay, so it's just a different way of doing it. You can do it with dollar signs, shoes, mustaches, bars of metals like aluminium and gold and silver, and all those. All right, now last one, and this is kind of important: continuous and discrete. So each one of these images goes with those. So the continuous is basically, it deals with small parts. Okay, think of things that you can get in the smaller numbers. Somebody's height. You can go down to, an 1/8 of an inch, a 1/16 of an inch, a 32nd of an inch. You can get smaller and smaller and smaller, and you can break those up. That would be a continuous graph if you were to do that. Okay. You can also think of this about weight of anything. You can go down to ounces, usually measuring anything. Populations, typically, you can go down to a single person, which depending on the range of numbers you have. But a continuous, you can get smaller and smaller and smaller numbers. Okay. A discrete graph, on the other hand, is one that jumps. So this would be, if you want to think about shoe sizes. Shoe sizes would be a discrete because we can't have a gap between, let's say, 7, 8, and 9. All right. You can't have one in between, you can't have anything in between. So it kind of jumps. That's a discrete graph. A discrete graph has jumps between them. Okay, there's set numbers that can't be changed. People's IQ is the same thing. You can't have a 151.5 IQ. It's 151 or 152. All right. Hopefully this has helped beginning of discrete descriptive statistics.